Hey guys, Buildzoid here, and we are back with the Biostar B550GTQ. I guess at this point you could call it a Buildzoid edition, but it still kinda sucks too much for me to want to put my name on it. It does suck less than it did before, but yeah, so as you can see, there's things have happened in the VRM section. We will take the motherboard apart, we'll take a look at all of that. So far, I've just replaced the inductors and also had to shuffle up all the replaced all the capacitors because I don't trust my desoldering skills enough to reuse the original capacitors. Also, I think the capacitor, like the thing is, I have excess supply of capacitors from when I first got into cap modding, and they're like the wrong size for what I want to use on GPUs and stuff. But this is a random motherboard that I don't care that much about, so yeah, I slapped some of my excess capacitors on here. Instead of just reusing the original ones. Anyway, it has been now running Prime95 for an hour and 17 minutes with the fan. Right, we have the fan over here. Right, this fan right here. Just blowing air onto sort of the VRM heatsink and the board and under the board because it is on I guess you could call it a test bench. Not really, it's a PCB blank with some standoffs on it, but yeah, anyway, so it's been running Prime95, and it sits at 90 degrees Celsius, and the room is really warm, because it's summer, and I don't have AC. The desk, random parts of the desk measure at, like, well, this corner of my desk measures 28 degrees. The other corner of my desk measures 26 degrees, so this is probably about 27 degrees in the room right now. The ceiling is at 20, yeah, the ceiling's approaching 27, the floor is at 24, so I'm going to say it's like 27 degrees ambient air temperature here. Yeah, it's running at like 90 degrees, so it's a bit warmer than when I originally did my original testing. And the temperature's starting to climb up because I closed the window. And this is a 3950X, so yeah, the room's gonna get quite hot very quickly. But anyway, max temperature, well, we just hit max temperature after an hour and 20 minutes. Also, it might be because I was messing around with the fan. I think it's more that the room is starting to heat up because I closed the door and window. Anyway, so yeah, it can now run Prime95 without overheating. And the interesting thing is, this is actually a slightly more aggressive PBO settings than my original testing. But actually what's still, well, ever so slightly more aggressive PBO settings than the original testing, because if I try to max out PBO, it actually still very quickly overheats, which is kind of, it's kind of interesting, and it also just kind of makes sense, because remember, there's two issues with this VRM. The power plane on this thing sucks, the connection between the CPU socket and the VRM is garbage, and then the VRM itself just had garbage inductors. So far, I've just replaced the garbage inductors and then had to deal with the capacitors not fitting anymore, because the bigger inductors are, well, too big for the original capacitor positions. So far, I've only replaced the inductors, and for Cinebench, the improvement is ridiculous. Like, the board runs, like, 15 degrees cooler. Okay, not 15. With the fan, it's like 10, like, a big improvement. Because, like, honestly, the improvement in the Cinebench was so big that I didn't really want to believe it. Prime95, we can actually run Prime95 now on PBO. So that's great, and this is a PBO with more aggressive settings than I originally tested, because my original testing was with 233.177.177 PBO limit, so we're just going to restart and go into the BIOS, take a look at that. Yeah, at this point I can't lose this take of the video. I don't feel like running Prime95 for another hour. It's like, this room is hot enough without a 3950X dumping 200 watts into the room. So, anyway, here's the glorious Biostar BIOS, and here we have the AMD CBS menu, and XFR. So, yeah, we're on 233.182.182. I originally tested 233.177.177. You might be like, isn't 182, like, barely a difference from 177? Well, yes, but the interesting thing is, if I set the PBO limit to just, like, if I set this from 233.182 to, like, 188, it'll actually start thermal throttling again. Like, it'll hit over 95 degrees. And that's kind of surprising, because you wouldn't think that such a small increase in current draw would make that big a difference. But the thing is, like, the power plane on this thing is still garbage, right? So I think what's happening, like, the problem there is basically, the resistance, like the heat output of the power plane, is a function of I squared R, right? Just how much current is flowing through the resistance of the power plane. So a small increase in current, actually, like a 10% increase in current flow through the power plane translates to about a 21% increase in heat output from the power plane. But that wouldn't explain why, you know, increasing the PBO limit by like 5% would make such a big difference to the operating, like to the VRM's operating temperature. But the thing is, the power plane, the resistance portion of that, you know, equation of I squared R depends on this, like, how the power plane is designed, like how large the cross section and how long it is. So like the actual shape of the power plane and what material it's made out of, which is copper, and how like thick it is, and the temperature it's at, because copper gets more electrically resistive the hotter it is. So if you know, slightly increase the amount of heat the power plane is producing, that means now the power plane is also running hotter, so that leads to the resistance increasing, which makes the power plane even less efficient, producing more heat and making it. And now, you know, the normally, and this is true for basically anything in terms of power delivery, where you have a feedback loop where heat translates into lower efficiency, translates into more heat, translates into lower efficiency and more heat. But the thing is, normally you have a heat sink, and at some point, or some kind of cooling system, and at some point the cooling system is just going to be removing heat from the heat generating component faster than the heat generating component can produce heat. However, this power plane is inside the board. There's not really any way to cool it. Like, it's not even exposed on the back of the board. There's no power plane on the back of the board. There's just that little, like, triangle on the front. So the thing is, you know, like basically you could get like thermal runaway on the power plane, I guess, where it would just heat up like it would heat itself so much that it would just eventually, I guess, like delaminate the board, which we're not going to go for that. But yeah, I just find it interesting that if I just set the PBO limit to like 188, it'll overheat, because I've done that. Like, I've tried several attempts to get this to not like over temperature protection, and at 182, it just about sits at 90 degrees. At 177, it sits at 87 degrees, right? And 87 degrees is a perfectly okay temperature for the VRM to sit at. I don't know what temperature the power plane is at, because there's no power plane temperature sensor. And also the power plane is inside the PCB, so not really a great way. Like, there's not really any way for me to measure it. But yeah, so at 182... it can just about hold Prime95 now, so that's neat. So the inductor swap, did it improve the VRM thermal performance? Yes. Did it improve it enough? No, because the power plane is still trash. Like, let's not forget, like in the Cinebench testing I did, the power plane was dropping like 20 watts of heat. Right? Like, if the power stages are producing 6 watts of heat, which theoretically, if the power stages are producing like, well, I'm going to have to pull up the notes. Where are the notes? So, yeah, so if the power... so at 150 amps output, which we're like right now with these PBO settings, we're somewhere between 150 and 200 amps output. So the power stages are producing somewhere between 12 watts and 18 watts of heat, right? Well, the power plane's producing 20, or probably pretty close to 20. So... you know, if the power plane is producing that much heat, like, the power plane's producing more heat than the VRM is kind of what I'm going for. So it makes sense that the inductor swap did not completely fix the VRM thermal situation. Also, I kind of suspect the thermal pads on this VRM kind of suck, because the VRM temperature sensor on the board, and it is accurate. I've checked it with a thermocouple. That's why we don't have like a secondary temperature sensor. I've already checked that works. So I'm perfectly happy to trust the motherboard's own temperature readings. But where was I going with this? Yeah, the thing is, the heatsink actually ends up at like a relatively low temperature. Relative to the temperature the VRM is reporting. So one of the things I want to mess with is like more thermal pad is sort of the next thing I want to do. And I don't want to do that for this video, because then it like screws up the results and the effects of the inductors. So in the next video, like the next video with this board will have the like power bridged version. But before I test the power bridge, I also want to do, which the power bridge is going to be the wires that are going to like bypass the crappy power plane. Well, they're not going to bypass, they're going to go in parallel with it, so, you know, if the electrons don't feel like going through the board, they can go, like, around the back of the board in order to get to the socket. And then, well, actually, the ground plane's fine, so it's really just VCore that we're going to be fixing. But, anyway, where was I going with this? Yeah, but I'll also do, like, a thermal pad test, because I really suspect that the VRM heatsink, which is pretty anemic, isn't really actually soaking that much heat from the board, because, well, the thing is the fan also, like, moves a lot of air, so I guess it might be, you know, the heatsink's getting cooled down a lot by the airflow that I'm providing, but it's just like, I still think the heatsink should be hotter than it is. I don't think it's getting as hot as it should be, considering that there's apparently like 90-degree power stages under it. So yeah, I want to mess around with the thermal pads. And then I'm also toying with the idea of just, like, sticking more heatsinks onto the board after doing the power plane thing. Where just, like, get this board to actually run, like, a maxed out 3950X. Because I am certain that it can do it. Just not in the factory configuration. So, yeah. Anyway, let's take a look at the actual modifications, shall we? So, there's the PBO settings, and now onto disassembling the board, which is unfortunately kind of fiddly, because... it has unnecessary, like, the I.O. cover has a lot of screws to it. So, oh right, I totally not consider the fact that we have to deal with the whole water cooling situation. I didn't clear enough desk space for it. Oh well. Yeah. Like, I wish this wasn't here, but the thing is, I did the original testing with the I.O. cover in place, so it wouldn't be fair to test it without it, because it is a pretty big airflow restrictor. Like, this thing is stupid thick. Like, this is actually... This thing feels, like, like, higher quality than what you would find on most other motherboards in terms of plastic I.O. covers, which is just like, well, that's priorities right there. 90 amp power stages, no power plane. Like, this board is just, like, a total, just, like, I think it's just a mess. Like, you have this... Like, it's still plastic, okay? It's not like a metal I.O. cover, which I think, honestly, if they just did, like, one of those MSI-style extended VRM heatsinks, where you just turn the heatsink into the top half of the I.O. cover. Like, I don't even... Like, why do you need a plastic I.O. cover? Like, you're not going to see the motherboard, because, like, you have this plastic part that goes down, but, like, you're not going to see the motherboard from this angle. Oh, I guess it's because putting RGB into metal is more difficult than putting RGB into plastic. Oh, well, I guess that makes sense. Anyway. Let go of my CPU, please. There we go. I hate 24 pins so much. There we go. I'm just going to leave the thermal paste on there. Actually, I'm not. I don't want to touch it. Up. Go. We don't need to pull the memory sticks, just need to pull these. So, yeah, anyway, like, the first thing you'll notice is these two capacitors, and that's just because the capacitors that I replaced the original ones with are lower capacitance, so I needed to add more capacitors in total, and so we're now up to 8 capacitors. One of them is a really big one, which you can see, and do I? Yeah, okay, I'll put that away somewhere. The floor works. So anyway, here's the back of the board. Yeah, this is where the original well, these are the new capacitors. So these are RR5 series Nichicon FP caps, 5 milliohms ESR each, 560 microfarads, 4 volts rated. So, yeah, very low ESR. The thing is, I don't know the spec of the original capacitors, and so the original, well, I know that they're 820 microfarads, and I know that they're 3 volts, but I don't know what ESR they are, so I was like, oh, well, we'll just go with 5 milliohms, because there's no way they're, like, these are, until recently, these were, like, the lowest ESR polymers that you could, like, through-hole polymers that you could get. So, yeah, that's why I went with those. I was also supposed to do some oscilloscope testing on this board, but I kind of decided to half-ass it. So we didn't do that because it's a pain, and I don't feel like dealing with it. I'll do some oscilloscope measurements at the very end when I have all of the when I've tested when I have all of the modifications in place, just because I'm wondering is the is the transient even any good? A transient response even any good? But nope, that's the wrong thing. So I have these standoffs for the backplate, and I'm just gonna move the camera a bit. There we go. So they have these standoffs for the I/O cover, and unfortunately they are not in any hex nut size that I have tools for, which is fun. So yeah, at least they use brass inserts, so they're not really the plastic I/O cover on this board is way too nice. It's got brass inserts. It's very solid, very thick, so even more of an airflow restrictor than if it was one of those flimsy little... a lot of the other manufacturers literally have, a single piece of plastic with some kind of, transparent inlay into it. And this thing is, this thing's, advanced plastic right here. Look at this. Right? And then you've got the brass inserts, which is all very nice, but it's just that none of this actually makes the motherboard a good motherboard. So... yeah, that's great. Anyway, here's the RM heatsink. It's not very big. I'm kind of annoyed by it because it's also it's not got a large flat surface that I can easily in the future I want to, well, I guess I could probably add some heatsinks to the back, just thermal tape heatsinks to it to give it more surface area. But yeah, it's just this shape is really not ideal for that. There's no large flat surface that you can just stack heat sinks on. You have a little bit up top. There's kind of in the back, but you can't really, you can kind of do this area right here, I guess. It's not great. Not a big fan of that in terms of modification support. Anyway, let's pull off the mounting screws. So, yeah, and I think I'll just do the power bridge, right over the socket. What I mean by that is, I can either put the power bridge under, because if I wanted to put the power bridge under the socket, I need to raise this, a couple millimeters, and I don't feel like dealing with that. It's really that simple. It's I'm very lazy. We are going to run the wires over the backplate, and then the downside to that is you can never replace the backplate. So anyway, here you can see my lovely inductor replacement job. It's horrendous, but in my defense, there just wasn't really any space, right? For these inductors. These are just way too damn big, which is why these are all at an angle, because I didn't want to accidentally, there's the ground points for the capacitors. I didn't want to accidentally short the inductors to the ground. So this runs, as you just saw, this was the board, the board was running. There's no LEDs on the well, no, there was the RGB on this. This should just have, this is the nicest piece of the entire board, and that's an insult. So anyway, yeah, so these inductors, these are 170 nanohenry. I have no idea what current rating they are, but they're huge by comparison to these, right? So these have less inductance. I believe they originally belonged to an HD7970 or something at some point in time. I have a box of spare inductors. Most of the spare inductors I have are off of dead Vegas and dead R9 290 cards. The problem with those is the Vega inductors are gigantic. Those things are absolute monsters. And the R9 290 card inductors are, well, I have I have them in sets of 5. And for whatever reason, not the I have them, yeah, the main issue is I have them in sets of 5, and this is a 6-phase, and so we can't use VR inductors that I have in sets of 5s, because I don't actually have, the same model of dead 290 regularly. I have multiple different dead 290 models, and so, There's like a Sapphire card that used like 170 nanohenry inductors with like extra surface area for cooling. Debatable if that actually works. Then there's a card from I think it was an XFX card that used 150 nanohenry inductors, which is like, okay, cool. But there's only 5 of those. Then there's some other 150 nanohenry inductors from a different card, which might be the same overall spec as the other 150 nanohenry inductors, but I can't tell because they're evidently a very different part number, even if they're roughly the same size and made by the same manufacturer. So I'm like, okay, well, I'm not going to mix those. So I ended up using these because these were the only inductors that I could find 6 of that were still like a size that would kind of fit. Like these don't fit. I also have inductors off of like a GTX 480, which would be, like that's a 6-phase, so I do have 6 of those, but those are like super long. So those wouldn't work, and those are even lower inductance. But yeah, so these inductors are much larger, and so they can just handle a lot more current, which we can very clearly see from the fact that I can now run Prime95 on this motherboard with PBO, with a bit more PBO than previously. So yeah, so the inductors are too small. I really wish I knew what actual what the DCR of these is, because like, there's a decent chance that these are because the thing is, when you look at, say, if you have a VRM in terms of like discrete MOSFETs, right? You have your high side MOSFET, which you don't really have to worry too much about the resistance of the high side MOSFET. It doesn't handle that much current, like it doesn't do that much, most of the current doesn't flow through it, so you don't have to be too concerned about the resistance of that one. Then you have the low side MOSFET, which handles anywhere between like 95 to 85, well, to 95 to like 80% of the current going through the VRM. And then you have the inductor, which handles 100% of the current to go through the VRM, which usually isn't a concern, because like you just don't buy a low DCR inductor. You just buy a big inductor with a high current rating, and you you call it a day. And then there's Biostar over here using, like, this is the kind of inductor I would expect to see for, like, the 5-volt power rail to run, like, a VRM on a GPU, or, like, the display drive. Like, this is tiny. This is absolutely tiny. Like, you can't see it on here, but this is one of the inductors off of a 290 here, right? We get autofocus? Yeah, so this is a V-core inductor off of an R9 290. This is spec'd for, I think, 60 or 70 amps. This is that 22, and this is 150 nanohenry, so this is even lower inductance, which basically just lower inductance means you can get more current capacity in a smaller size. So here's the 22, and you could, like, fit, like, 2.5 of those into that 290X V-core inductor. Actually, maybe 3 of them. Maybe 3 of them. Right, like, absolutely tiny, and with more inductance. So this is probably like maybe a third of the current capacity of this, which is not great, right? Because actually no, it can't be a third, because then you'd have, like, if those were like 30 now, like if it was half the current rating, then you'd have like 30 amp inductors on a 6-phase, which would give the total current capacity for the VRM of like 180 amps. Which is, like, not enough. Like, that's nowhere near enough for a motherboard that you can, PBO a 3950X in. So, yeah, like, the stock inductors are just kind of garbage. Also, I added a bit of wire over here that you can see. The idea behind that was just to try compensate for the fact that, like, the power plane loss, just, like, even in the VRM itself, like, from here to here, we were losing a lot of voltage, so that wire is to help a little bit with that. Also, I had to scrape the solder mask in order to get those inductors on there, because obviously they're just way big. Like, you can just look at this one. This one has the same footprint as the ones currently on there. This is actually, like, the exact same size, but yeah, you can see that I had to scrape solder mask because there was just no way the replacement inductors were fitting, and then still having, like, the heatsink fit properly. So yeah, it was quite an adventure getting those on there. But luckily, like, the nice thing about this board being 4-layer PCB with basically no power plane is that it actually doesn't take a lot of heat, right? So the soldering, like, it is still a mess, but at least it took a lot less effort than, well, like doing this on a GPU or like a 6-layer motherboard with like a proper power delivery system is way more difficult than on this thing right here. This is kind of a function of me not caring that much. Anyway, so yeah, so this, and then for the capacitors, this big one is 1500 microfarads, because the original VRM used 6 820 microfarad inductors. Man, this room is getting so hot. Anyway, yeah, so originally we had 6 820 microfarad inductors, which I replaced with 7 560 microfarad inductors, and then that one 1500 microfarad inductor, capacitor. Oh man, the heat, it makes it hard to think. It really does. Man, like, this room sucks so much in the summer. Anyway, yeah, so now we have there's overall a little bit more capacitance than this started with, using 8 capacitors instead of just 6, so it should be slightly better transient response. The inductor upgrade works, but man, is it a, like, pain to do. Board still runs. It runs, like, it's a bit more, like, it runs less hot. I don't know that it should be less, like, it should be more power efficient. Like, you know, like, the temperature of the VRM is mostly a function of how much, like, how inefficient the VRM is, and then what heatsink it has. Yeah, so that's that. That's the Biostar B550GTQ inductor upgrade, and I'd say, yeah, the stock inductors are definitely too small. These might be kind of overkill, because these are off a 7970's V-core, so they're probably like 60 amps each, but I don't know, I think that's a good fit, you know, for like 90 amp smart power stages, you should probably be using like 60 amp inductors, right? Not 30s. Like, those could be even like these could be even 20 amps. And if these are 20 amps, then it's like, yeah, no wonder it overheats in 3 minutes in Cinebench. Like, these are so so undersized for what they're supposed to be like, for what you can actually like run in terms of settings on the board, that it's like, yeah, that's a bad idea. I mean, like, this isn't the first time I've seen, like, well, no, the only other example I can think of, like, really underspec inductors is like the memory power rail on reference 980 Ti's and reference Titans from NVIDIA. And those cards will, like, burn those inductors eventually, which is really weird. These are made of metal. Okay, these are made of metal. There's no silicon in these. Or actually, I don't know that there's no silicon in them, but there's no, like, active components. They're just a bit of fancy wire with a very fancy, like, core material around that fancy piece of wire. And so it's like, yeah, how, like, and like Biostar over here trying to replicate NVIDIA's memory power delivery. So, yeah, anyway. And then the next thing is we're just going to be running wires from these capacitors to the socket. So, yeah, and hopefully that gets this board to run unlimited PBO, which it might. Like, it really might, because, yeah, I don't know. Like, I'm not yet sure what size wires I want to use. I'm kind of toying with, like, on one hand, I kind of want to be lazy and just, like, run 18 gauge or something to the socket. On the other hand, like, I want to, like, the thing is, there's not really, I didn't really notice, like, a nice, like, ground, well, no, power, like, there's not really, like, a nice area that I could, like, scrape off the solder mask to solder the power bridge to. So basically, I'm going to be, like, attaching the power bridge to the multi-layer ceramic capacitors. And that's just going to be really awkward to do. Yeah. So, anyway, there, that's part 1 of modifying the B550GTQ into not sucking. I mean, it's very ugly now, but it does run. And, like, I mean, the heatsink, like, the nice thing is the heatsink almost entirely obscures from view the modifications. So, you know, if you don't know what's hiding under the heats, I can't get it on there. Where's this? Oh, screw it. Anyway, see? It's fine. You can't even see the big capacitor anymore. So, yeah. Anyway, so yeah, now step 2 is just fix the power plane, and we'll see if I can get the board to actually get like the full 90. Well, okay, we're never gonna get 90 amps out of those power stages, but like it would be nice to be able to run like 200 amps through the board and not have it try to set itself on fire, like it currently does. Or like just being able to max out PBO. Like that's because maxed out PBO is around 220 watts of CPU power draw. Like at least my 3950X really doesn't want to go above that in my experience. So it's like, yeah, I'd like to be able to max out PBO without the board trying to set itself on fire. You know, that would be like, and we're not even talking like static overclocking or anything. So yeah, that's next, is just upgrade the power plane, and yeah, that's it for the video. So thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, then I have a Patreon and a Teespring store. Which, I mean, in this case, we're just using components I've had. Well, the equipment that I use to do this horrible soldering job, of course. Thank you, patrons, for you know, funding a lot of it. As well as Teespring, of course. So, yeah, Patreon link, Teespring's link down in the description. Much appreciated if you check those out, because they help out immensely with running the channel. And that's it for the video, so thanks for watching, and goodbye.